Hi there. For this video, we'll be solving quadratic equations. Specifically, we'll apply the first method and how we can get the quadratic equation, and that is by factoring. So let's dive into this example. Let's have x squared plus 2x plus 1 equals 0. So most of the time, this is our goal setup. To have one side to be equal to 0, and to have this side with the other terms, especially the variable x squared. So how do we solve for x in this one? First, note that our goal is to factor this. And observe that this trinomial is actually a perfect square trinomial. Indeed, x squared out here is a perfect square, since the square root of x squared is equal to x. 1 here is also a perfect square, since square root of 1 is equal to 1. And observe that if we multiply this 2, x times 1 times 2, we'll obtain this one. So by perfect square trinomial, this out here factors into x plus 1 squared. Bring down the equals 0. And now, when we have this, we observe, when will this equality hold? The only possibility is that if this expression out here is equal to 0. So we take note that this is true if x plus 1 is equal to 0. From here, it's just simple linear equation. So we move 1 to the other side to obtain x equals, remember, when we move a term to the other side of the equation, we change its sign. So this becomes negative 1. And this one out here is our final answer. Let's go on to our second example. Let's have 3a squared minus 12 equals 0. Again, our goal is to set up the equation like this. So we are good since we have one side to be 0 and the other side to contain the other terms, including the squared variable. So to factor this one, first, note that 3 is a common factor in each term. Indeed, we can write this one as 3a squared minus 3 times 4 equals 0. So we can extract this 3 outside of this. So we'll have 3 times a squared minus 4 equals 0. Now from here, let's observe, when will this equality hold? Since this one can never be 0, our only hope to make this true is to make this one out here be 0. So we'll have a squared minus 4 equals 0. And let's focus on this one. We actually have two ways to solve this. So let's go with our method 1. With method 1, we can simply just factor this one out. So observe that this one is a square out here, 4 is also a squared since this one is equal to 2 squared. And since it is separated by the minus sign, then we can apply the difference of two squares. So we'll have a plus the square root of 4 is 2 times a minus 2 equals 0. From here, take note, when will this equality hold? So I keep repeating that one since that idea is very essential in understanding this topic. So this equality will hold if either of these two is equal to 0. So we have a plus 2 equals 0 or a minus 2 equals 0. Solving this linear equation, we will obtain a equals negative 2 or a equals 2. And that is the answer. Now another method that we can do is have method 2. If we have this a squared minus 4 equals 0, what we can do is we can transfer this term back out here. So we'll have a squared equals 4. And from here, we can apply radicals. So we can get the square root of these two, and we'll obtain a equals 2. But note that since we're dealing with a square root here or an even radical, this outcome must be positive negative, since positive is for the principal root and negative is for the secondary root. So in either cases, we get the same answer. Let's have this third example. Let's have x squared plus 7x equals negative 12. Since the form of the equation is not our desired, we first transfer this one to the left side. So we'll obtain x squared plus 7x plus 12 equals 0. And from here, our goal now is to factor this one. So how do we factor this one? We apply our knowledge on how to factor general quadratic trinomials. So to do that, we first focus on this one. Observe that 12 can be factored into 12 times 1, 6 times 2, 4 times 3. To determine the right combination, we observe the middle term. Since the middle term is positive 7, we try to check which combination out here that when we get their sum, the outcome is 7. Clearly, the only possible is 4 and 3, since 4 plus 3 is equal to 7. And so, we know that this one factors into x plus 4 times x plus 3 equals 0. And again, when will this equality hold? This equality will hold if either one of this is equal to 0. So we have x plus 4 equals 0 or x plus 3 equals 0. Solving the linear equation, transfer this out here to obtain x equals negative 4 or x equals negative 3. And these are our answers. Let's have our fourth example. Let's have 3b squared minus 2b minus 5 equals 0. Since the equation is already in our desired form, our goal now is to factor this one out here. And how do we factor this one if there's a coefficient on our leading variable, which is b squared? We can apply the slide and divide method. So if you don't know this, you may check out my video on factoring quadratic trinomials. So basically, we first slide this variable to the last term. So we'll obtain b squared minus 2b, negative 5 times 3 is negative 15. And then we factor this like how we did a while ago. So focusing on negative 15, the possible factors of negative 15 are negative 15 times 1, 15 times negative 1, what else? Negative 5 times 3, and 5 times negative 3. Since we have negative 2 out here, the only combination that when we add those numbers will give negative 2 is negative 5 and 3. Since when we add this is equal to negative 2. So this one factors into b minus 5 times b plus 3. Now is this done? Not yet, since we haven't applied the divide method. So recall, we did slide here, and the number that we slide is what we will divide in this part. So we divide 3 out here. Simplifying, we obtain b minus 5 over 3 times b plus 1. And at this point, we can now bring down the equals 0 part. And so, when will this equality or equation hold? It will hold if this one is equal to 0 or this one is equal to 0. So we've got b minus 5 over 3 equals 0 or b plus 1 equals 0. Simplifying these linear equations, we'll obtain b equals 5 over 3 or b equals negative 1. And that is the answer. Let's have this one final example. Let's have 10m times m minus 2 equals m plus 10. Now if you look at this one, it might seem that there are no variables with degree 2. Does that mean that this isn't a quadratic equation? Well, there aren't any variable of degree 2 out here since we haven't simplified it. Observe that when we multiply this one out here, we'll obtain 10m squared minus 20m equals m plus 10. And so we now have a variable of degree 2. From here, again, our goal is to move every variable in one side of the equation and leave the other side to be 0. So doing that, we move m to the left side and then to the left side. So this will give us 10m squared minus 20m, then m from right to left will give us negative m, and then 10 when moved to the left side or to the other side of the equation will be negative. So this is negative 10 equals 0. Simplifying this left side, we'll obtain 10m squared minus 21m minus 10 equals 0. Let's clear out some space. And so from here, our goal again is to factor this side of the equation. To do that, we'll again apply the slide and divide method. So we first slide this 10 out here to obtain m squared minus 21m minus 10 times 10 is 100. Factoring this one, first focus on negative 100. So we got negative 100, listing out all its possible factors. So buckle up since this will be quite a lot. So we have negative 100, 100 and negative 1. We also have negative 52, 50 and negative 2. What else? We've got negative 25 and 4, 25 and negative 4. What else can we multiply to obtain this? We can also multiply negative 10 and 10. Are we missing something? Yep, we're missing the negative 20 and 4 and 20 and negative 4. Since our middle term is negative 21, we try to find the right combination that when we add will give negative 21. You can verify that it will be negative 25 and 4. Since when we add this, it will give us negative 21. So we know that this one out here factors into m minus 25 times m plus 4. From here, we now apply the divide method. So from the slide out here, the 10, we divide 10 out here to obtain m negative 25 over 10 when simplified is negative 5 over 2. M plus 4 over 10 when simplified is m plus 2 over 5. We can now bring down the right side of the equation. So let's resize this first. Save some space. And now, this equation will hold true if this one is equal to 0 or this one is equal to 0. So we've got m minus 5 over 2 equals 0 or m plus 2 over 5 equals 0. Solving for these cases, we'll obtain m equals 5 over 2 or m equals negative 2 over 5. And that is our final answer. Although this is the last example, I want to leave you with something that you can think about. What if we have, say, u squared plus 6u minus 5 equals 0? You might think that to solve this, we simply apply how we factor quadratic trinomials. But upon checking negative 5, its only possible factors are negative 5 and 1, and 5 and negative 1. However, none of these adds up to our middle term, which is 6. So we can't really factor this one easily. Does that mean that there isn't an answer for this one? Well, the answer is there is an answer for this one. And we will solve that in the next video. If you want a head start, the method that we will use here is called completing the square. So to formally end this, here are two exercises that you can work on. First, we have 2z squared minus 6z equals 20 and 2b squared plus 11b plus 15 equals 0. So yeah, I hope you enjoyed this video. Feel free to comment down below your answers to these exercises as well as your solutions if you can. Hope you enjoyed this one. And that's it. That's all for this video.